So double or half angle formula, it's all relative. Let's look at this double angle identity. Cosine 2 alpha, right? This is 2 alpha is a double angle of alpha. Sure. But what if I replace alpha with half of theta? Let's call it half of theta. Then twice of half of theta will be theta. So it's possible we write it differently to see this. If that is theta, then this is just half of theta. The formula becomes, see, cosine theta 1 minus 2 times sine square half of theta. So just for you to see the double angle identity, now with a change of variable, it becomes some identity involving theta and half of theta. Yeah. So we can, from here, we can try to derive a half angle identity, because I just want to isolate this half angle, and then let's solve it. Let's solve the equation for sine square half of theta. So all we need is to add to the equation, right? So both sides. So you just add this quantity to both sides of the equation. Then we left-hand side becomes that. And we can also minus cosine theta. So this both sides of the equation. So once you add, this two will be canceled. The twice of sine half of theta, and then minus cosine theta. So it's a 1 minus cosine theta. So this becomes, yeah, we just solve and put the sine square half of theta on one side and 2. And then was next step, we divide 2. If you divide 2 both sides, you see sine square half of theta is half of this quantity. So it's not difficult to arrive at this identity. It is called half angle identity because you see when you have the half of theta, right, you can solve for the sine of half of theta using some cosine value of theta. But we still want to take a square root because this is a sine square. So we want to take a square root to get a sine value of half of theta. After you take a square root, you can get either positive or negative square root. So either positive or negative. So the sign can be determined based on the position of half of theta. Yeah, we know the sign either positive or negative, right? Depending on where half of theta is. Okay, so now we got the first half angle identity for sine. Half angle identity for sine. And this is an identity that is essentially the same identity. It's just that identity written differently. Correct? This identity, you see, if we write if we view this one as theta, then this one will be half, right? Because 2 alpha alpha is just like theta compared to its half. So that's all. It's essentially the same formula, but this time we want to focus on, yeah, this version, so we can solve this equation for sine half of theta. Once we solve this equation for the sine half of theta, we get a half angle identity. So now this is the first half angle identity, and you might be curious about cosine of half of theta. How can we find cosine of half of theta? So let's think of double angle identity again. And this time we use another version of the double angle identity for cosine. Here, suppose alpha is replaced with theta. If this alpha, 2 alpha, is replaced with theta, then 2 alpha versus alpha, right? So that means if this 2 alpha is theta, then alpha must be half of theta. Yeah. So immediately, you see the formula becomes this, because all I did is 2 alpha. We do a change of variable. 2 alpha becomes theta. So then left-hand side becomes cosine theta. The other side, alpha will be half of theta. So now this relates the cosine of a half angle. So then, yeah, this two, what's the difference from here to here? It's just a change of variable, the same identity. But now we can look at how can I get a half angle in terms of the function of the angle. So let's add 1 both sides. So if we add 1 both sides, so this will be gone, and this is 1 plus. And then we divide 2 both sides. If you divide 2, then this is gone, and divide 2. So then we can get cosine square of a half angle equals this quantity. But how do you get cosine half angle? Yeah, take a square root. So now it is, after we solve this equation, right, adding 1 and divide 2, yeah. So first you add 1, then second you divide 2, you get cosine square of a half angle. So cosine square of a half angle, that's still not good enough. Then we take a square root to get. So if you take a square root, then this square will be gone. So you can get either positive or negative square root to decide the cosine of half angle. Okay, so we get this formula. So cosine of half angle is either plus or minus square root of this quantity. So now we get a half angle identity. That is, whenever you want to calculate cosine of half angle, you can use this formula using cosine of the angle plus 1 over 2, and then take a square root. But whether positive or negative square root, depending on the position of half of theta. Okay, so here's a second formula. So, so far we have derived sine of half of theta. That's the half angle formula. Now, cosine of half of theta. And if we know sine, cosine, just do a division, we can get tangent of half of theta. So let's look at what we have so far. And cosine of half of theta, right? That's one formula. That is sine of half of theta. And then cosine of half of theta, another formula. And if we divide the sine half of theta by the cosine half of theta, then we get tangent half of theta. So we can get half angle identity for tangent. So let's just simply do a division. So this divided by this, right? We get tangent half of theta. So let's see what this will become. And this divided by this quantity, so we get, because the two, will be canceled. So you can see it will become this identity. So very easy to verify. So it's just this sine of half of theta, which is either plus or minus 1 minus cosine theta, over cosine of half of theta, which is either plus or minus half of 1 plus cosine theta. Yeah, so you see I'm doing a division using the sine of half of theta over cosine of half of theta in order to get tangent, right? That's tangent half of theta. And the numerator and denominator, if we multiply by square root of 2, if we multiply, then this 2 and the square root can be canceled with this. This 2 can be canceled with that. So the formula is reduced to this one. So numerator, denominator, so we can still, after the quotient, it's either positive or negative. How do we determine to take positive or negative? Then based on the position of half of theta in the first quadrant or second or third, so that the sign is depending on that extra information. So now you have 3 half angle formulas for sine, cosine, tangent. We don't need 6 half angle formulas, right? Because once you know the sine value of half angle, you can get cosecant of half of theta by reciprocal property. Yeah, once you know the cosine value of this angle, half of theta, you can get secant of half of theta. Once you get this, you can get cotangent half of theta. So reciprocal property will allow us to find the other 3 trigonometric function values of half of theta. So, okay, now we have 3 formulas for, these are half angle formulas for sine, cosine, and tangent. That's sufficient for our use. And let's look at one example. Use half angle formulas to find exact value of sine 75. Let's think of the sine 75. So we want to find exact value. But according to the formula we just you just learned, so that is either plus or minus, right, square root of half of 1 minus cosine twice of this angle, which is twice of the 75. which is 150. Yeah, we can simply put 150. Twice of that is 150 degrees. So, and 75 is an acute angle, so we know we don't need a negative sign. So you can erase the negative sign. That means it's a positive square root of this quantity. So let's continue from here. So what is cosine 150? Cosine 150 degree, its reference angle is, well, 150 has a reference angle 30, right? So we know cosine 30. Cosine 30 is square root of 3 over 2. However, cosine 150, 150 is in the second quadrant, so the cosine value is negative. So it's a so now we have 1 plus, because 1 minus negative of this number is 1 plus this number over 2 and the overall square root. However, you can still write it as, because 1 over 2, right? This is square root. For example, we can write the numerator as you can combine the 2 plus square root of 3, because 1 is 2 over 2, right? I try to add these two together, this 2. 2 over 2 plus square root 3 over 2, right? So we can add the fractions once you so that's, you can possibly add, then over another 2. And then we get the 4 in denominator. 2 plus square root 3 and square root 3. So you see 4 is a perfect square. 4 is 2 square. So it can be outside of the square root. So it's just 2. That's the square root of 4, which is 2 in denominator. And then numerator will be 2 plus square root of 3. So that is our final answer, this quantity. That is a sine 75 degree. So sine 75 degree, after we apply the half angle identity, yeah. So this, we can use the special angle 150 to evaluate, to get exact value of sine 75 degree. By using half angle identity, we actually decided it is positive, right? Because 75 is in the first quadrant. Yeah, so the rest is simply evaluation. Similarly, cosine 75, we can compare. What is the difference? Sine 75, we did it using the half angle identity. You see, 75 is viewed as half of 150. So using the half angle identity, which is this, right? We take a positive sign for the square root. So this is a positive sign for the square root, not negative. And then the cosine 150 is this. It's a special angle. So then we continue to evaluate. This part looks um, a little, yeah, the number not so neat, but as long as you think, okay, first of all, we just need to do this fraction, right? You have to handle the fractions, but this one can be viewed as 2 over 2, right? You can do this. Yeah. So just 2 over 2 minus a negative means a plus. So that's how we get this numerator first. That's 2 over 2. So 2 plus square root of 3. And then this whole thing will be divided by 2. Remember, when you divide the 2, it's the same as multiplying a half, right? So this quantity numerator divided by 2 is same as multiplying a half. So that's why we have this 4 now in denominator. So if you multiply these two things, you get 4 in denominator. And numerator is simply 2 plus square root of 3. And the whole thing is under the square root. So that's why we get this. And after that, take a square root of 4, because this is square root for the whole numerator and denominator. So square root of denominator can be just simply calculated, right? Square root of 4 is 2. So, but square root of the numerator is just, we leave it as is. Okay, so now we got the sine of half of 150, which is sine of 75 degree. The cosine 75 degree, very similar. The formula is either plus or minus, right? Because the 75 is just half of this angle. So we could again use half angle identity, but for cosine, half angle identity is half of this angle for cosine. Then we can use either plus or minus, since 75 degrees is an acute angle. So we still take a positive sign. It's in the first quadrant. So cosine is positive. Only take a positive square root. And then it's half of 1 plus cosine of this angle. And then cosine of that angle is this value we already used earlier, right? Cosine of 150. And now the only difference is 1 plus this value compared to the, you see, half angle identity for sine is 1 minus cosine of this 75 degrees. Yeah, 1 minus cosine of the double angle of this. So you see this, the only difference. Then you proceed like very similar. And then you get the final answer for cosine of 75 degrees.